Hi dear, my name is Ogodino Uche Jude. Hope you are keeping safe. Welcome to this mathematics online class. Our topic for discussion, or the topic I'll treat, is sine rule. So let's go. So by the end of the lesson, the student should be able to derive the sine rule, use the sine rule to solve triangles, applying the sine rule to real life situations such as bearing and distances, angle, and elevation. So given any triangle ABC, acute and obtuse angle triangle are given below. So we are just going to go through this um, proof, and after the proof, we'll continue from there. So just hold on a sec. All right. Now, given triangle ABC and another triangle ABC, this is acute and this one is what? Obtuse. So let's go to the next slide. Now, we want to prove that A over sine A is equal to B over sine B equal to C over sine C. So construction, draw the perpendicular from A to BC. This is the perpendicular from A to BC. So this is your B, this is your C. This is the perpendicular we are drawing from A to BC. So prove sine B is equal to H over C, sine C is equal to H over B. Let's go back. Sine B, this is sine B. This is your B. Your B is here, big angle B. Now, another thing you should understand when we are dealing with sine rule or cosine rule, which we will treat later, in triangles, the angles are capitalized. That means they are in capital letter. So this capital letter A representing this angle, this capital letter B representing this angle, this capital letter C representing this angle. So the sides are represented by small letter. This is small c, this is small b, and this is small a. So the side facing the angle is called a small letter. Look at the big angle A. This is the line or the side facing the angle. So it's represented as small a, small b, and small c. So from that proof, our sine b is equal to h over c. Then our sine c is equal to h over b. Now, that's the next triangle, we have A and B. This triangle A and this triangle B. So in this triangle B, this angle sine C is equal to H over B. But this C is 180 minus C. Why? Because this place and this place, if you add these two together, angle in a straight line, it gives you 180. So this place is 180 minus what? Theta. Anything that is given to you as theta. So that's why this place is 180 minus alpha. Okay, I'm using alpha this time around, equal to sine alpha. So from the first one, sine B equal to H over C. If you cross multiply and make H the subject of the formula, C is equal to H is equal to C sine B. Going to the next slide. Then the other one, H is equal to B sine C. Now, if you make H the subject of the formula in both cases, it therefore means that our C sine B is equal to B sine C. So B should go, this one, divide both sides by sine B first. You have B over sine B. Then divide this side by sine C, you have C over sine C. So similarly, by drawing a perpendicular from C to AB, by drawing a perpendicular from C to AB, then we have A over sine A equal to B over sine B. Therefore, A over sine A, this is the formula we are looking for. A over sine A equal to B over sine B equal to C over sine C. So this is the sine rule. It's used for solving triangle which are not right angle. That is true. When you are given question in mathematics and you are asked to find the angles and the sides, and that triangle is not a right angle triangle, then you don't need Pythagoras theorem. You only use Pythagoras theorem when you are solving a right angled triangle. But any other triangle, isosceles that is not right angle, and other kind of triangle, equilateral and the rest, you solve them with what? Sine rule, depending. So let's go on. Which are not right angle, in which either two angles. So if two angles on one side are given, then you use the sine rule. So in triangle ABC, B is equal to 39 degree, C is equal to 83 degree, our B is equal to 39 degrees, then our small a is equal to 6.73 centimeter. Then you are asked to find A. So we are asked, so please hold on a sec. So we are asked to find C. Now that we are asked to find C, before we go over to the board, let's draw the diagram and let's see how to solve this. This is a triangle given to us. So this is our B, this is our A, and this is our C. 82 degrees, 39 degrees, 29 degrees, then 6.73 centimeter. So we are asked to find C, small c. So if you're looking for small c, it's very simple. So I will go over to the board, to the marker board now. So welcome back. Going to the marker board, we are looking for C. Now, if you're looking for C, this is your big C, then this line is your small c. This is your big A, this angle is your big A, then this one is your small a. Then this one is your what? Small b. So we are asked to look for small c. So if you're looking for small c, that means we need one angle that is complete and one angle that is what? One that is complete, both angle and side. So this one has side, but does not have angle A. But we can get angle A by simply what? Subtracting from 180. So angle A plus angle B plus angle C is equal to 180 degrees. What's the reason? Sum of angle in a straight line. Sorry, sum of angle in a triangle. Angles in a triangle. So what is angle A? Okay, let's complete like I taught you before. You can leave it like this, but it's not matured enough. So B and C, A and C, A and B. So that's a complete labeling. Now, our BAC, that's our angle A, is what we are looking for, plus angle B has been given to us as 39 degrees plus 82 degrees equal to 180 degrees. So BAC is equal to 180 degrees minus, add this together, that should give us 9 plus 2, 11, carry 1. 8 plus 3, 11 plus 1, 12. So BAC will now give us, subtract, let's subtract, collect 1 from this or borrow 1 from this. This will give us 9, 7. 7 minus 2, 5. 1 minus 2, 59. So this is 59. So with that, we now have one side complete, one angle complete. Then we can use the one we are looking for. What am I saying? Let's just use the board instead of talking. Hope you've gotten this. So I'm wiping it out. So we have now C over sine C is equal to A over sine A. So pardon me, I want to get the question back. So that is C over sine 82 equal to, sorry, I need to draw this diagram so that you understand. Sorry for even cleaning the diagram. So let me draw the diagram again and use the diagram to explain. So this is B, this is A, this is C, 82 degrees, 39 degrees, 6.73 centimeter. So I don't need this again. Going back to the board, stop share. Okay, back to the board. So this is what I'm doing. We are looking for small c, and we have, this is A facing this, so small a. So c over sine c, small c is what we are looking for over sine c, which is sine 82, equal to, then our a, small a is what? Yes, 6.73 centimeter over sine A. We recall we got what? 59. We got 59 here. So that is what? 59 degree. But it's sine. So that should give us sine 59 degrees. So we got 59 degrees. So this gives us now, making C the subject of the formula or cross multiply, C times sine 59 is equal to sine 82 times 6.73. So if you make C the subject of the formula, that will give us what? Sine 82 times 6.73 over sine 59. Hope you understand. So because I'm not with calculator now, I'm going back to the slide to get the answer. So this is a step. I just want you to understand everything that we have in the step. All right, going back. So this is it. We are going to get 7.775. 7.775 centimeter. Hope that example 1 is clear. So going to example 2. So example 2, find the remaining angles of a triangle in which A is equal to 12.5 centimeter, C is equal to 17.7 centimeter, and C is equal to 116 degrees. 116 degrees. So wiping the board now. All right, drawing the diagram. This is the diagram. So this is the diagram. This side is obtuse, 116 degrees. So that's why it's wide. Obtuse angle, centimeter, 17.7 centimeter, A, B, C. So what are we looking for? Find the remaining angle. So what are the remaining angles? We are looking for this angle and this angle. So you are looking for A and this. So let's proceed. Going to the board now. So going to the board, we have what's complete here. This is A and this is what? Small a. This is the angle A. Look at the line facing it. So this is small a. This is small b. Look at it. Small b. We don't know small b. Although we are not going to look for this because they said find the remaining angles, not solving completely. Then this is small c. So the only one that is complete there is what? Small c. So with the help of small c, we can get every other one. So we don't have anything that has to do with b, but we have a. So that means we can say a over sine a equal to b, small b over sine b. So what's the a now? 12.5 centimeter over sine a. Do we have sine a? Okay, we are looking for sine a first. Equal to b. So what's the b there? No, we don't need b. So I should add c over sine c. So this one will not be used now because we don't have it. So let's use c over sine c. So what's c? Small c is 17.7 centimeter over sine c. This is the angle. So sine 116 degrees. Then since you're looking for sine A, cross multiply. So sine A times 17.7 centimeter is equal to 12.5 centimeter times, that's 12.5 times sine 116 degrees. So sine A, being the subject of the formula now be 12.5 centimeter times sine 116 all over 17.7 centimeter. So we get our A. So our A, sine A, will now be equal to whatsoever we get as sine A, we look for the arc sine of that. Arc sine of that, I'll get an angle. So I don't want to be going through the slide, coming back to the board. So I'll explain what I'm going to show you now in the slide. So when you use sine arc to get your A, you get the angle, you add this plus this, subtract from 180 because the total angles in the triangle give you what? 180. So going back to the slide. Okay. So this is it. This is what we've solved. Then with that, we are going to get 39.4 degrees. 39.4 degrees. So this place is 39.4 degrees. So add this and this to get B. So why did they give us two angles? In case sometimes you are not sure whether it is acute on angle, acute or obtuse, what they're trying to do here is 39.4 degree is the right answer. They subtracted from 180 in case it's, but this angle is not an acute angle. They is small. Acute angles are angles that are less than 90. Look at how acute angles will be formed. But obtuse will be wide, like this one that is wide. So but C is not obtuse, therefore A cannot be what? Obtuse. So that's why they said A cannot be obtuse. Now, we convert 3940 to what? 39.40 to degrees. I'll tell you how to convert to degrees later, but the answer is what? 24 degrees. So like I said, if you want to now get angle B, that's angle B, this angle B here, you add the two angles, this plus this subtract from 180. Then you convert to what? Degrees. Like this, 24.6 degrees or 24 degrees, 36 seconds. So this mark you're seeing here, like apostrophe, in mathematics represent minutes. Minutes. Okay, hope you got that. So in triangle ABC, A is equal to this, B is equal to that. So let's look for the triangle. So this is the triangle. So are we solving completely? They said in triangle ABC A is this, B is this. So solve the triangle completely. So we are solving completely. So if you are going to solve completely, okay. Diagram, example 3. So this is the diagram. 63 degrees, 18 minutes, 9.5 centimeter. This is A, B, C, 7.1 centimeter. So in this particular question, the only thing complete there is, let me stop the sharing. Okay, in this particular question, the only thing complete there is what? Is this and this. That's B. B is the only complete one. So if this is B, that's the angle B. This is a side. Side AC is small b. So this is my small b. So line AC is equal to what? Small b. So I've not been doing this in order to get you confused. So this is the AC, small b, AB, small c, BC, small a. So what are we going to do? But before we convert, let's convert this 18 minutes to what? To degrees. So 60 minutes is equal to what? 1 degree. So 18 minutes is equal to what? X. If I cross multiply, that will give me 60x is equal to 18. So x is 18 over 60. So what will go? 3 here, 6. 3 here, 20. 3 here, 2. 3, 20. 3 here, 2, 10. No. Let's go over it again. Let's use 6. 6 here, 3. 6 here, 10. So x is what? 3 over 10. So this 3 over 10 is 0.3. So adding it to 63. So 63.0, 0.3. That will give us 63.3 degrees. So our angle, hope you've gotten this. I want to rub this one off, but leaving a diagram. So our angle B in degrees and not in degrees and minutes is what? Angle B is 63.3 degrees. Sorry, excuse me. So we have that now. So which one are we going to solve now? Let's look at it very well. If we are going to solve this, of course, we know that B should be there because B is complete. B over sine B is equal to what was given to us? A. So we can get A. Small a over sine A. So what is our B now? Our B is 63.3 over sine B is what? What is your sine B? Sine, or rather small b, sorry for that, small b is 9.5. Then your big B is sine 63.3. Mind you've converted already, equal to A. We have 1 there. So small a is small a. Small a is 7.1 centimeter over what? Sine A. So we can get the angle. If we cross multiply, that gives us sine A equal to sine 63.3 times 7.1 centimeter over what? 9.5 centimeter. So sine A, we give whatsoever the answer will give us, then A will now be arc sine, and so on and so forth. So when you get A, you can now add this and this, subtract from 180. So let's go to the slide to see what I'm saying. So that will give you 41.89. Then you can have the 2, but if you look at it, there's no obtuse angle there. So your right answer is 41.89 degrees. So what next? Subtract, like I said, add this and whatever you get here, subtract from 180 to get this. That's what you are seeing here now. Then if you want to get big C, very simple now to get big C. If you want to get big C, I don't want to continue on the board now. So if you want to get big C, what do? You say C over sine is equal to B over sine B. Already from your calculation, after you've added this and this and subtracted, you can get whatever you want to get. So just fixing this complete one, B over sine B, use that, then C over sine C. Sorry, this is not 74.810, but sine 74.81 raised to power 0. And that raised to power 0 is degree. So that's sine 74.81 degrees. Then you can get your what? C. You look for arc sine and you get your what? Your C. So when you get your, no, sorry, you are not looking for arc sine because this is small c. This a typographical error. It's supposed to be that's small letter c. So you do it directly, don't get arc sine, and you get your side. So when you get that side, you've gotten 1 angle, 2 angle, 3 angle, and you can get the other side. So, okay, let's go back to the board. Going back to the board, this is what we are saying. When you add, I'm not going to add now, just explain. When you add this plus your answer, you get this answer. So whatsoever you have here now is enough for you to get what? Your C. And this now, you use this one that is complete. That's B over sine B equal to C over sine C. So this B is this over sine B is this all over C. By then you've gotten this because you got this already. You added this plus this and you subtracted to get this. So there's an angle here. You now use this angle, that's C over sine this angle, cross multiply, and you get your answer. So hope you understand. Going to the board again, or back to the slide rather. Let's go to the next example. Okay, I think that's the last one before go to bearing. Okay, so we are now in bearing. Application of sine rule to bearing and distance. A tree is on a bearing of south 36 degrees west from, I think it's from a tree. Okay, let me move this one a bit. Okay, yeah, from a point X, and south 78 degree east from a point Y. If X is 200 meters due east of Y, calculate the distance of the tree from Y to the nearest meter. So if you are going to do that, I'm going to draw the diagram. Let's draw the diagram. So that should be example 4. All right, I'm going to interpret this diagram, but when I finish interpreting, then you look at what I've done. Okay, maybe I should write the question so that I'll use it to a tree is on a bearing south 36 degrees west from a point X and south 78 degree east from a point Y. If X is 200 meter due east of Y, calculate the distance of the tree from Y to the nearest meter. All right, going to the board for interpretation. All right, so if you are to solve this now, a tree is on a bearing of south 36 degree west. Now in bearing, if you want to get bearing, we have 4 cardinal points: north, south, east, west. So this kind of bearing notation is called compass bearing. It's called compass bearing when you have southwest and the rest. So southwest 36. If you are using southwest 36, this is, if you draw southwest like you are making a mistake, this is west south. So southwest 36 is like this. And mind you, everything here is 90. Let me show you something. North, south, east, west. This one is 90. This is 90, but sometimes if you are using normal bearing, you are not using, you are using 3-degree bearing. You are going to be drawing it like this: 90, 180, 270, and what? 360. So, but you know that 90 plus 90 plus 90 plus 90. So all of them are right angle, right angle, right angle, right angle. So, and you move clockwise. Don't move like this in bearing. You move clockwise. Hope you've gotten that. So I'll wipe this one off. Okay. Now, southwest 36. You are starting from here. So I'll take any point as my what? Southwest. And I'll write 36 degrees here. southwest 36. So it therefore means if I subtract 90 minus 36, I will get what here? 54, right? Okay, so that is the first one. A tree is on a bearing. So this is the tree on a bearing of whatsoever. I'm going to reduce this because I don't have much space. I'll manage the space I have. So this is a tree. They said from a point X, from. Another thing again is from. If they say from, the bearing should be from that point. So they said from X. So this is X. Now, and south 78 degrees east from a point Y. So because I've done this before, I know. But when you are trying it, you might not know the actual spot. Maybe you try here or somewhere here, but north, south, east, west. So this is what they are saying. They said south 78 degrees east. So southeast. This is how southeast should go. Please, not east, south, southeast 78 to join to this one. So 78 degrees. So that is it. And this point is point what? Point Y. Now, if X is 200 meters due east of Y, when you hear due east, it means straight, no angle, just move straight. So if X is 200 meters due east, this is east. So X is 200 meters, mean you join them together, 200 meters due east of Y. So calculate the distance of the 3 from Y. 3 from Y. So this is what you're looking for. You know what you should do? Draw another triangle. After you've interpreted the question, draw another triangle. Then you bring out everything you've interpreted. This is Y. This is X. This is T. This is 200 meter. If this place is 78, and we know that everything here is supposed to be 90. Everything here 90. So 90 minus 78 will give us what? 12. 90, 78. So 12 degrees. This place is 12 degrees. So this place now is 36, but we want what is inside. And this place is 90. So 90 minus 36 will give you what? 90 minus 36. That should give you 54. So let's try it. 4. Yeah, 54. 54 degrees. Hope you understand. Hope you understand what I've just done. Okay, I'll go over it again. First, let me say that I can make it bigger so that you see. North, south, east, west. These are your 4 cardinal points. So a tree is on a bearing of south 36 degrees west. So 36 degrees west. So 36 degrees west from a point. Let's put the 3 here. 3. This is from a point X. Then, can I make this one bigger so that you can see? So north, south, east, west. South 78 degrees east. So 78. Or you can make it longer to show it 78, but that does not really matter. So join this one together. If X is 200 meters due east of Y, 200 meters, this is our east, 200 meters. So this was our initial diagram. I said, in order to solve now, you bring out the word diagram. So from this diagram now, I really can continue now. So we are looking for YT. This is your Y. Distance from T to Y. Calculate the distance of the 3 from Y. Okay, so I'll clean this now. I'll draw the smaller diagram. We use that smaller diagram to solve this. So this is what we are going to do now. Draw this, draw this. This is your Y. This is your X. This is the 3T, 200 meter. So we said everything here is 90. So 90 minus 78, 12. This place is 12 degrees. This place is what? 90 minus this should give us what? 54 degrees. So we need to get this one. So if you want to get this now, add this and this together, that should give us 66. So 180 minus 66. Minus 66. What are we looking for now? Angle T. So 180 minus 66, that should give us 4, 1, 1. So 114. Am I correct? 6 plus 2.1, 7 plus 1, 8. Okay, 114. 6 plus 4, 10, carry 1, 6 plus 1, okay, 114 degrees, I'm right. So that is the angle. I'll clean this now. I suppose you understand already. Now, what next? We are looking for this. So this is small x as usual. We are looking for yt. So yt is small x. Then this is small t. Then this is small y. So which one is complete? We have two complete now, this and this. So x over sine x is equal to, we are looking for x over sine, we are looking for x and we have this already. Then we use the one that is complete, t over sine t. So what is the x there? That's what we are looking for, sine x. This is sine x, this is where x is sine x. So sine x is what? 54 degrees equal to, what's your small t? 200 over, yep, sine t, sine 114 degrees. So if you cross multiply, x will now give us this times this divided by this. Sine 54 times 200 divided by sine 114, and you get your what? Your answer. So very, very simple and straightforward. Let's go back to our slide and see the answer there. So we are going to get 177.1 meter. So going to the last question. Two ships, A and B, leave a port, so at the same time. A travels on a bearing of this, and so on and so forth. So let's interpret. Let us interpret. So I'll still write the question because I need the question for interpretation. So example 5, two ships, A and B, leaves a port at the same time. A travels on a bearing of 159 degrees and B travels on a bearing of 215 degrees. After some time, A is 9 kilometers from P and the bearing of B from A is 256 degrees. Calculate the distance of B from P. Okay, I hope this part of the board will be able to contain what we are going to interpret now. All right, two ships, A and B, leaves a port at the same time. A travels on the bearing of this and B on the bearing of this. After some time, A is from, okay, from two ships travel from a point P. So they are traveling from port P. This is the first one. Of course, north, south, east, west. Now, this one now is not compass bearing, but 3-digit bearing. Okay, now that we're using the 3-digit bearing, 159. 90 plus 90. I said start like this clockwise. The way your clock move, 1, 2, 3, 4. Don't start like this. You are going to miss it. So start clockwise. So 90, 159 should be around here. It's not up to 180. So you draw something like this. Sorry. Okay. So this is 159 degrees. And this is A. This is your A. This is your point P from the port. That's where the ship is moving from. So a port at the same time, A travels on a bearing of this and B travels on a bearing of 215 from the same port. So you start 215, 215, 90, 180 is not to 215. This one will be 270, so it should be within 270, but don't cross 270. If you enter the next one, it's 360. So 215. So from this place to this place, 215. Because I can't write 215 here, I'll use arrow to indicate that this second line is 215. 215 degrees. So that is it. Now, this is A, this one is B. They said now, After some time, A is 9 kilometers from P. So 9 kilometers from P. And the bearing of B from A. B from A. So the bearing should be from here. If it is A from B, you draw it here. But they said B from A. So let's go. Draw something like this. So north, south, east, west. So they said the bearing of B from A is 256. B from A is 256. So this is how the bearing will go. This is A. Already we know that this point is point A. So 256 should be where? Yes, you are right. Not here, not here. Yeah. Okay, 256. So this is a point for 256. So all this one now is 256 degrees. That's the bearing. So you know what I'll do? I'll clean this diagram so that this triangle can touch. So yes, this is the right triangle. So this is our point, what? B. That's right, our point B. Now, the problem now is not actually a problem, how to get the angles inside. Okay, if you want to get the angle inside now, if from this place to this place is 215, look at it too. From here to here, 215. And this other place now, from here to here is 159. How am I going to get this point P? The way I'm going to get this point P is very, very simple. From here to here, 159. So 159 plus something will give me 215. It therefore means 215 minus 159 is what is going to give me this place. So 215 minus 159. And that is what? Let's do it together. 215, 159, 0. So this is 6, 5. Are we correct? 6. Yes, you are correct. So this point is 56. All this point is 56 degrees. Now, how do I get this point? If from this place to this place is 256, then to complete it, what is it going to be? Very simple. That will give me what? The complete one is what? 270. Look at the line, please. Maybe I should draw the line so that you see it. From this place to this place is 256. So this remaining place will have completed 270. So it needs 14 more to get to 270, or 270 minus 256. That will give us 14. So this particular part is 14 degrees. So 14 degrees. Then how do we get this place? Very simple. You remember Z angles. So how do I get this place? Look at this one. This is a Z angle. If I get here, I can get here. But first, let's get this place. From this line to this line is 159, right? Look at it. From this place to this place, 159 degrees. So for me to get this angle outside, it should be what? Yes, you can tell me. 90 plus what to give me 159? So invariably, I saying 159 minus what? 90. This is 90 and the total is 159. So 159 minus 90. So let's do that together. 159 minus 90. No. So this is 9. And this is what? 6. 69, right? Yes, 69. So this place is 69 because of Z angle. We already have here 69 degrees. So alternate angles. So this part is what? Alternate. Add 69 plus this, that should give us what? 383. So that is 83. So what you should do now is, I don't need this one anymore. I'll wipe it out. What I need now is a triangle, not a right angle triangle, because you don't apply sine or cosine rule to right angle triangle. So I will draw another triangle that looks like this one. This is 83 degrees. We've got 56 degrees here. This is P. This is 9 kilometers. This is my B. What else again? So what are we actually looking for? Oh, can't remember again. I think you're looking for this point. Let's check. So this is my what? My A. So we can actually get this by adding this and then let's look at what we are looking for. Well, I think we are looking for BP. Yeah, B from P. So that we are looking for. We're looking for this side. So going back to this to the board. So this place is what? Small a. We are looking for small a. This place is what? Small p. This capital letter P. So small p. And this place is what? Small b. So we can actually make this one complete by adding. That's 180 degrees. If you're looking for B, angle B, 180 minus 56 plus 83. So angle B will now give me 180 minus, that's 9, 139. So angle B will now give me 180 minus 139. That should give me 141 degrees, right? 4 plus 110, 4 plus 3, 7, 8. Yeah, 41 degrees. So this place is 41 degrees. So it's complete now. So which is the complete now? B and B. So B over sine B is equal to, we are looking for A, angle BP. BP is actually what? A. You understand? Or let's do it here. Angle BP is equal to small a. So I'll put my small a all over, yes, sine A. So what's my B? 9 over sine 41 degrees is equal to A. That's what we are looking for, over BA, over sine A. That's sine 83. So cross multiply. A will now give me 9 times sine 83 all over sine 41 degrees. So you get your answer. Wow. So we get our answer. That's BP or BP is equal to whatsoever the answer. Going back to slide to see the answer. So we are going to get 13.61 kilometer. So she B is 13.61 kilometer from B. So that's the end of the slide, and that's the end of today's lecture. So with this, I hope I've done justice to this topic. Please make sure you do your assignments. Make sure you practice. Mathematics is just what? Practicing, 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 and you become what? Perfect. So until we meet again in our next online class, my name still remains Mr. Ogodino Uche Jude. Ciao.